Welcome to Asian Teachers Maps. Today let's talk about ratio. So imagine you're in a park and the engineer designed to arrange stuff like this. So see bench, tree, bench, this is like a set. And then bench, tree, bench, and a set. Between two sets, there will be a bin. And the next one here will be a bench, like here. So if you continue like this will be a bench, tree, bench, and then bin, and then bench again. Okay, like this. Same goes for this side. In this situation, the number of bin, tree, and benches are variables because we don't know how long the path will be, but we know the pattern. So their ratios can be expressed as bin to tree to bench is 1 to 2 to 4. Okay. So ratio basically is the relationship between variables. It stays the same given in a same situation. So in this situation, it remains 1 to 2 to 4. We have 1 bin, 2, 3, 4 bench here. Or what if there are more? So if there are more, we like this. So 2 to 4 to 8 or 3 to 6 to 12 and so on. These are all the same ratios, just with bigger numbers. Okay. However, we should always use the lowest number when possible because it's the simplest. And from here to here, everything is divided by 2. And then from here to here, everything is divided by 4. However, to here, it is the simplest already because if we divide further, then we'll have fractions or decimals. And we don't want to see that in a ratio. So wherever we have the lowest integers possible, then it is a good way to represent the ratio. Okay. So with the pattern fixed, we can deduce how many of something will be. Even let's say we have 50 bin here. How many trees do we have? Oh, the number of trees always doubled of that of bin. So we'll have 100 trees. And how many benches should we have? Oh, the number of benches is always 4 times than that of bin, which means it's 4 times 50, there will be 200 benches. Or you can say, oh, the number of benches is always 2 times of tree. So then we'll have 200 benches from 100 of trees. Okay. So in here, we can use an equation to represent their relationship. Let's say bin is small b and tree is small t. Then I can say b is equals to half t or 1/2 times t. As you can see, the bin to tree, bin is always half of depth of tree. 3 is half of 6, 4 is half of 8, 1 is half of 2. So we can say b is equals to 1/2 times t. And here 1/2 is the k, which is the proportional constant. Okay. So whenever two variables have the fixed ratio to each other, then we can express it like this. This speed equals to k1t. Use k1 here because I have k2 in that place. Or I can also say that the number of trees is always 2 times of bin. 6 is 2 times of 3, 8 is 2 times of 4. Then we say t is equals to 2 times b. This will always be true. And can also be expressed as t is equals to kb or k2b. This is also a proportional constant. So this variable can change, but the proportional constant will not change. So similarly, between bin and bench, you can see that bench is always 4 times of bin. So bench is equals to 4 bin. Or you can say the number of bin is always a quarter of bench. So bin is equals to 1 over 4 times bench. Okay. Or expressed with a proportional constant. K5 is 1 over 4. K6 is 4. Okay. Overall, between tree and bench, actually you can see that bench is always 2 times of tree, and tree is always half of bench. So we like this. Bench is 2 times tree, and tree is half times bench. Okay. And they work really like fraction. So see the ratio 1 to 2 and 2 to 4 are actually the same ratio, isn't it? Similarly, for fraction, they talked about previously, the fraction here, 3 over 5 is the same as 6 over 10. It is like the ratio 3 to 5 is the same as the ratio 6 to 10. They're the same ratio. Then we'll be using this one as a percent ratio because it has lowest integers. In an example here, I can use fraction to represent them. So between bin and tree, the fraction is 1 over 2, which is equals to 2 over 4, like here, then equals to 3 over 6, like here. So next, let's do a little bit of example of how to reduce ratio. Let's say we have 12 trees. How many bins should be there? Okay, 12 is not here, so let's calculate. So now, given that bin to tree is equal to 1 to 2, we figured this out previously. In here, so which means B is directly proportional to T. So this is a fish symbol that represents directly proportional. And when two variables are directly proportional, it means that they can be expressed in this form. B will be equals to KT. Okay. Then, since we know that one of their possible pairs between B and T are 1 and 2, there's still 1 and 2 here, we'll find K. We can also substitute 2 and 4 here. We get the same results for k. Then you find that k is 1 over 2, which means b equals to kt is actually b equals to 1 over 2 times t. And we have the equation to understand the relationship between b and t. Okay. And now we know that we have 12 trees. So from the equation, we substitute 12 into t. Like this. Oh, then 12 times 1 over 2 will be 6. And we know that the number of bins will be 6. Okay. So this is like the orthodox way to the full way to do this. However, we have quick curve method. So let's say, okay, it's the same question. So, being the tree, we all know that the ratio is 1 to 2. Okay, ignore bench a bit for here. And then, and we know that tree, now we have 12 trees. And the ratio still remains the same. So it's an equal sign here. The ratio is the same ratio in here, b to 12. We just don't know what is b yet. Okay. Then we can multiply 12 to 1 over 2. Then we get b. So basically, we just skip all these steps and then go to here. Okay. However, hard to do without doing all the steps. So we can also do this one. This means b over 1 is equals to 12 over 2. Just like b over 1 equals to 12 over 2. And then we'll get the same results for b as 6. 12 over 2 is 6. This one can also be reversed. We can also say 1 over b is equal to 2 over 12. This also works, same as this one. We just do the reciprocal of both sides. Okay. And the next one, this is also possible. It's like b over 12 is equals to 1 over 2. Because it works like fraction, remember? So, this is a fraction. I'm expressing ratio in a fraction. And they are the same ratio, which means they're the same fraction. And here we can also find that b is equal to 6. Okay. By the way, and this one works because we are like tracing backwards in this situation. Just like from here to here, we divide everything by 4 to trace backwards. So there will be a 2, 3, 4, 5, 6, 6 to 12 to 24 somewhere here. And from that one to the original one, I divide everything by 6, right? So this is asking, how many should I divide by to the b? 12 divided by 2 is 6, or 12 divided by 6 is 2, which means if I divide b by 6, I should get back 1, which means 1 times 6 will be b, which means b is 6. Okay. Or we can just say that, all 3 of these are the same expression anyway. Right? So then all of them will be correct. Okay. And ratios appear a lot in our daily life. So this is a road sign showing how steep of a slope is. So say 1 to 4 here, It means that if we lay out the slope like this is the horizontal displacement, this vertical displacement. This is the right angle, which is 90 degrees. Okay. Then y to x will be 1 to 4. This 4, this is 1. Okay, like this. This 1, this 4. This is 4 meters, it 1 meter. 4 kilometers, 1 kilometer. Yeah. As long as there's the same unit, then it is okay. We can also find k, which is the gradient or slope in here, to represent the steepness of the slope. So in here, k is 1 over 4 using previous method. So because I can substitute y is 1, x is 4. So 1 is equals to k times 4. Then k is 1 over 4. So the slope will be 1 over 4. So if another instant we say 1 to 2, that will be a much steeper slope. Because it will be something like this. This is 1 to 2. Okay. You see, this is much steeper because this is shorter, but the vertical displacement doesn't change. Then the gradient will be 1 over 2, which is a larger number. Larger positive number means that it is a steeper slope. So in here, k is equals to 1 over 2. In the road side, we'll say 1 to 2. Or the side looks like this. It's a 25%. It means that if the horizontal displacement is 100 units, and meters, kilometers, and vertical unit is 25 meters or kilometers, as long as both of them use the same unit. Okay. So then we can see that y to x is 25 to 100. This is y, this is x. Then it's 1 to 4. And the gradient is also 1 over 4 because k is 1 over 4. So these two slopes actually has the same steepness. Another way you can use ratio is to finding the aspect ratio when we are doing some graphic design or like animation design, video design. So let's say we have to design a postcard with 16 cm to 6 cm. So x to y will be 16 to 6. They're the same unit, so you can say the aspect ratio will be this lowest integer to represent this ratio, which will be 8 to 3. So it's like doing fraction. 16 over 6. Oh, can be simplified. So let's simplify that. Okay, divide both the denominator and denominator by 2, which is 8 to 3. Oh, this will be 8 over 3, or 8 to 3. Okay. So that's why we have 8 to 3 here. Okay. Oh, and then I want to like put in the value in the software, like the graphic editing software. So usually in setting of the ratio, we'll see some trend here, which means the ratio we fixed. So if we put in 8,000 pixels in the width, then the software will automatically give us 3,000. If we have already told the software that the ratio should be 8:3. Okay. If we unchain this button, then these two will not be like in a fixed ratio. Then we have to put in both of them individually, manually. So also for the resolution, it's just something like, oh, the resolution on the screen is like 1280 times 720. So we always put the horizontal first, the X first. Then it means the ratio will be 1280 to 720. And we simplify this ratio, we see the aspect ratio is actually 16:9. Okay. So we can divide both of them by 80, which is the HCF. Then we'll get this aspect ratio. So we can try dividing both of them by 80 and see what happens. Okay. So this is for ratio. Next one will be about proportional and diversity proportional. And yeah, see you in the tutorial.